Hello friends, welcome to Middle Geekers Academy. Today we'll discuss third exercise of polynomials, that is division algorithm of polynomials. Recall, we have studied division algorithm in real numbers, the first chapter. It was a equals to bq plus r, where a is dividend, b is divisor, q is quotient and r is remainder. The same division algorithm can be applied for polynomials with the notations: let p of x be the dividend, g of x be the divisor, q of x be the quotient, and r of x be the remainder. So by dividing p of x by a polynomial g of x, we can get quotient and remainder. Let's solve question number 1. Divide the polynomial p of x by the polynomial g of x and find the quotient and remainder in each of the following. So in the first example, p of x is a cubic polynomial, whereas g of x, the divisor, is a quadratic. Write divisor, dividend in their respective places. So x cube minus 3x square plus 5x minus 3. Divisor is x square minus 2. Now to divide one polynomial by another, we must compare the first terms of both divisor and dividend. Here the first term is x square and here the first term is x cube. We must compare powers of both the terms. Second, coefficients of both the terms. Since both have same coefficients, powers are different. So if we multiply this divisor by x, we'll get x cube. So this is the first step. Multiplying by x to the divisor, we get x square into x, that is x cube. 2 into x is 2x, that we will write below 5x. As usual, subtract. So it is minus and plus. X cube gets cancelled. So minus 3x square plus 7x minus 3. Now you can compare again the divisor and the new dividend. Both have same powers, differences of coefficients. So by which term you will multiply in order to get minus 3x square? Yes, it is minus 3. So multiply divisor by minus 3. So we get minus 3x square minus 2 into minus 3 is 6. Change the signs. Now here 3x square gets cancelled. 7x minus 3 minus 6 is minus 9. Now again compare powers of dividend and divisor. Here the power is 1, which is less than the power of divisor. You can divide only in case when the degree of dividend is greater than or equals to the degree of divisor. So further process stops. Here only we get quotient q of x as x minus 3 and remainder as 7x minus 9. So in this way we can divide a polynomial by another polynomial. Similarly, we can solve second example. Second example, here dividend is a polynomial of degree 4, whereas divisor is a polynomial of degree 2. If you observe, I have written a term of x cube, but with coefficient 0, which was not given in the dividend part. So arrange all the terms in dividend. Now let's start the process. If we compare the coefficients, yes, they are same. So only the thing is to multiply by x square. So x square into x square gives x raised to 4. X square into minus x is minus x cube plus x square. Subtract. So minus plus and minus, x raised to 4 gets cancelled. The new dividend is x cube minus 4x square plus 4x plus 5. Again, the coefficient of x square and x cube are same. So multiply this x square by x. So we get x cube minus x square plus x. Subtracting, x cube gets cancelled. New dividend is now minus 3x square plus 3x plus 5. Now the degrees of both divisor and this new dividend are same. Now only the thing is to multiply by constant. So multiply x square by minus 3. So minus 3 into x square minus 3 into minus x minus 3 into 1. Change the signs, plus, minus and plus. 3x square cancel. Coincidentally here 3x also gets cancelled. 5 plus 3 is 8. So the dividend, so the quotient is x square plus x minus 3, whereas remainder is a constant polynomial, that is 8. Third example, here dividend is a polynomial of degree 4 and divisor is a polynomial of degree 2. Rearrange the terms of divisor, though they have given 2 minus x square, but we'll write it as minus x square plus 2. Insert two terms, x cube and x square, in order to rearrange the terms of dividend. Now the first quotient will be minus x square. On multiplying it with minus x square will give x raised to 4. Minus x square into 2 is minus 2x square. Subtracting, x raised to 4 cancel. Now here 0x cube. Let us check later on whether x cube is required or not. Here 2x square minus 5x plus 6. Now if we multiply this term by minus 2, we'll get 2x square. So the second term of the quotient is minus 2. Minus 2 into minus x square is 2x square. 2 into minus 2 is minus 4. Change the signs. 2x square gets cancelled. Minus 5x plus 10. Further division process stops as the degree of this new dividend is less than the divisor. So we get quotient as minus x square minus 2 and remainder as minus 5x plus 10. Let's solve question number 2. Check whether the first polynomial is a factor of the second polynomial by dividing second polynomial by the first polynomial. On dividing first polynomial, if we get remainder 0, then we can conclude that first polynomial is a factor of second polynomial. Let's solve first bit. Here 2t raised to 4 plus 3t cube minus 2t square minus 9t minus 12 is to be divided by t square minus 3. The first multiple will be, yes, 2t square. Multiply 2t square with t square. It gives 2t raised to 4. 2t square into minus 3 is minus 6t square. Subtracting. So 2t raised to 4 gets cancelled. Take 3t cube now. 6 and minus 2 is 4t square minus 9t minus 12. Now multiply t square by 3t in order to get 3t cube. Minus 3 into 3t is minus 9t. Again subtracting. 3t cube gets cancelled. Now we have 4t square. 9t also gets cancelled. Minus 12. In order to get 4t square, multiply by 4 now. So we have 4t square minus 12. Subtracting gives remainder 0. Since remainder is 0, we can conclude that t square minus 3 is a factor of the polynomial 2t raised to 4 plus 3t cube minus 2t square minus 9t minus 12. Second bit. Here the first polynomial is quadratic, whereas the second polynomial, means dividend, is of degree 4. So divide 3x raised to 4 plus 5x cube minus 7x square plus 2x plus 2 by x square plus 3x plus 1. Now, by which term you will multiply this x square? By 3x square. So 3x square into x square gives 3x raised to 4 plus 9x cube plus 3x square. Subtracting 3x raised to 4 gets cancelled. 5 minus 9 is minus 4x cube minus 10x square plus 2x plus 2. Now, in order to get minus 4x cube, we must multiply by minus 4x. So minus 4x cube minus 12x square minus 4x. Subtracting the terms. So 4x cube gets cancelled. 12 and minus 10 is 2x square. 4 and 2 is 6x plus 2. In order to get 2x square, multiply by 2. So it is 2x square plus 6x plus 2. Changing the signs, we get remainder 0. So as remainder is 0, we can conclude that x square plus 3x plus 1 is a factor of the polynomial 3x raised to 4 plus 5x cube minus 7x square plus 2x plus 2. Now come to third bit, where divisor is cubic and dividend is a polynomial of degree 5. So let's check. X cube minus 3x plus 1. Dividend is x raised to 5 minus 4x cube plus x square plus 3x plus 1. The first term to be multiplied with x cube is x square. So we get x raised to 5 minus 3x cube plus x square. Subtracting, x raised to 5 gets cancelled. Now we have minus x cube. X square also gets cancelled. Plus 3x plus 1. Now in order to get minus x cube, multiply by minus sign. So minus x cube plus 3x minus 1. Change the signs. So plus, minus and plus. X cube cancel. 3x also gets cancelled. 1 plus 1 is 2. As we are not getting remainder 0, since remainder is non-zero, x cube minus 3x plus 1 is not a factor of the polynomial x raised to 5 minus 4x cube plus x square plus 3x plus 1. Question number 3. It is obtain all other zeros of the polynomial 3x raised to 4 plus 6x cube minus 2x square minus 10x minus 5 if two of its zeros are root 5 by 3 and minus root 5 by 3. Since root 5 by 3 and minus root 5 by 3 are zeros of this polynomial p of x, we can take x minus root 5 by 3, x plus root 5 by 3 as factors. On multiplying these two factors, we get x square minus 5 by 3. That is 3x square minus 5 upon 3. So we may say 3x square minus 5 is one factor of the polynomial p of x. So let us divide p of x by 3x square minus 5 to get the second factor, or we may say to get another two zeros. P of x is 3x raised to 4 plus 6x cube minus 2x square minus 10x minus 5. So multiply this divisor by x square. So we get 3x raised to 4 minus 5x square. Subtracting, 3x raised to 4 gets cancelled. 6x cube plus 3x square minus 10x minus 5. Now multiply by 2x. So 2x into 3x square gives 6x cube minus 10x. Again on subtracting, 6x cube as well as 10x both gets cancelled. 3x square minus 5, which is same as the divisor. So multiply divisor by 1, we get 3x square minus 5, and on subtracting we get 0. So the quotient, this quotient q of x, is supposed to be the other factor of the given polynomial p of x. So we can write other factor of p of x is x square plus 2x plus 1, which is perfect square of x plus 1. So you may write x plus 1, x plus 1. Therefore, other two zeros of p of x are minus 1, minus 1. While writing zeros, you have to take opposite signs from the factors. So these are the required two zeros. Question number 4. On dividing polynomial x cube minus 3x square plus x plus 2 by a polynomial g of x, we get the quotient and remainder as x minus 2 and minus 2x plus 4 respectively. Find g of x. Recall Euclid's division algorithm. We can write p of x as g of x into q of x plus r of x. So p of x is given, it is x cube minus 3x square plus x plus 2. G of x is to be determined. Q of x is x minus 2 plus r of x is minus 2x plus 4. Take this factor to the left side. So we get x cube minus 3x square plus x plus 2 plus 2x minus 4 equal to g of x into x minus 2. That is, g of x into x minus 2 is x cube minus 3x square. There are two terms of x. So 3x, 2 and minus 4 is minus 2. So in order to get g of x, we must divide x cube minus 3x square plus 3x minus 2 by x minus 2. So x cube minus 3x square plus 3x minus 2 is to be divided by x minus 2. Multiply divisor by x square to get x cube minus 2x square. Subtracting, x cube cancel. So we have minus x square plus 3x minus 2. Multiply by minus x. We get minus x square plus 2x. Again subtracting, x square cancel. So we have x minus 2, which is same as divisor. So multiply divisor by 1, we get x minus 2. And on subtracting, remainder is 0. So this quotient, x square minus x plus 1, is the required g of x. So required g of x is x square minus x plus 1. Now let's switch to last question of this exercise. Question number 5. Give examples of polynomials p of x, g of x, q of x and r of x which satisfies the division algorithm as well as the given conditions. In first, the given condition is degree of p of x must be same as degree of q of x. So in order to satisfy this condition, if we take p of x as 2x square minus 2x plus 14, take g of x as 2, q of x, since we need degree of p and q to be same, so let q of x be x square minus x plus 7 and take r of x as 0. So by division algorithm, by using division algorithm, p of x equals to g of x into q of x plus r of x. P of x we had considered as 2x square minus 2x plus 14, g of x as 2, q of x as x square minus x plus 7, and we had considered r of x as 0. On multiplying bracket by 2, we get 2x square minus 2x plus 14. So here LHS equals to RHS. So in this way, we can choose P of x, Q of x, G of x and R of x, and also which satisfies the condition that the degree of P of x is same as degree of Q of x. Second bit, here we must have degree of Q of x same as degree of R of x. So let's fix P of x, G of x, Q of x and R of x as x cube plus x square plus x plus 1. Take G of x as x square minus 1. So if we take Q of x as x plus 1 and R of x as multiple, say 2 into x plus 1, that is 2x plus 2. Now let's check division algorithm. P of x equals to G of x into q of x plus r of x, x cube plus x square plus x plus 1. G of x is x square minus 1, q of x is x plus 1, r of x is 2x plus 2. Let's simplify right hand side. So it is x cube plus x square minus x minus 1 plus 2x plus 2. That is x cube plus x square minus x plus 2x gives x, and minus 1 plus 2 is plus 1. So division algorithm is also satisfied. Now come to third bit. Here the condition is that degree of r of x must be 0. Degree of r of x must be 0 means r of x must be a constant term. So let us fix p of x, g of x, q of x and r of x as x cube plus 2x square minus x plus 2, g of x as x square minus 1, q of x as x plus 2. And since degree of r of x must be 0, let's take r of x as 4. By using division algorithm, p of x equals to g of x into q of x plus r of x, that is x cube plus 2x square minus x plus 2, x square minus 1, q of x is x plus 2, r of x is 4. Multiply brackets, x cube plus 2x square minus x minus 2 plus 4, that is x cube plus 2x square minus x plus 2. So LHS is same as RHS. So division algorithm is also satisfied. So in this way we can choose the polynomials p of x, g of x, q of x and r of x. So this completes the chapter polynomials. Thank you.